Hello and welcome everybody to a basement update. Solar storage system. What we've got here is the system. It's been running since April 2022, so 1.5 years by now. Here's the 1.6 kilowatt hour battery, voltage boosted by those LFP cells here. Then I'm using an Eltec Flatpak server power supply for charging the batteries, and a Chinese grid tie inverter for, well, working in grid parallel to save on energy. And then here we've got the control system, which is very messy, so let's not look at it for too long. This control system takes over a number of tasks, and we will take a look at that upstairs. Now, let's take a look at the operation of this. So this is the overview page. It's got all the historical data and the current data. And well, you can see even now in winter it's doing something. It's currently charging the battery at 84 watts, and yeah, rather than feeding in the energy unpaid into the grid, I save it in the battery. What has it done until today? We have put 688 kilowatt hours into the battery. That equates to like 200 euros of paid electricity in 1.5 years, so it's not massive. And we've taken out 611 kilowatt hours. That's the losses of the system. Most of all, the Chinese inverter is quite lossy, like 85% efficient. Then you can see here there's still some PV energy that we haven't used. Mostly happens when we are on holiday, for example, and then, well, we can't use electricity, so it goes into the grid unpaid. And then here you can see how much energy has been put into the car, and that we might be in for a surprise here. So overall, since I started measuring this, we have drawn 300 kilowatt hours from the grid, and 1900 of those went into the car. So you can say the solar system almost offset our domestic power usage for cooking, fridge and all that, and the car comes on top of that. And we can also see the use of the solar system if we go back in the year where it was summer. So here, for example, in July we only needed 50 kilowatt hours from the grid. That was all. In June 60, May 137, that was a bit more. August 103, and then you can see the later in the year, the more we take from the grid. So that's also kind of depicts the efficiency of the solar system. Let's look at a more or less typical summer day. That would be this one right here. So we started charging the battery sometime early in the morning. Here we are probably making breakfast, and then we charge the battery all before noon, and we keep charging. At some point you can see it's full because we're putting energy into the grid, and that's when I run downstairs and plug in the car, set it to a low charge power like 2 kilowatts, and then the solar power and the battery power combined do charge the car. And I let this run until the battery is empty, and then I unplug it. And let's see what this works out to. That would be July 5th. Here it is. So we put almost 5 kilowatt hours into the car, but only drew 1.7 kilowatt hours from the grid. That's what we want. Now, you may be wondering what happens to a solar storage system in winter when there is no sun to store, or hardly any. Well, let's also take a look at that. And maybe for introduction, I've mentioned it in previous videos, we are now using a electricity provider that charges spot market prices. So what does that mean? Let's take a look at that briefly. Here is the energy mix in Germany since November 10th. And the blue is wind, yellow is solar, and then the dark stuff is the evil fossil stuff, black and brown coal. And then this gray stuff is gas, natural gas. And you can see the fewer coal we need, the more electricity prices drop. And this is probably a weekend, but doesn't have to be. So during the nighttime hours, it's from midnight till 5 o'clock in the morning, electricity prices drop to like even negative prices. And I have programmed the battery to start charging when price drops below a certain threshold. So during these hours I will charge it and use the energy when energy is expensive. So I don't discharge it right away, but only when energy is like in some peak, like this one right here. This is last weekend. And now you can see prices rise again. Yes, and the electricity provider that I'm using charges basically this spot market price plus, well, unfortunately quite a lot of fees, like grid usage fees, taxes. Anyway, you can save on your electricity bill, and we will see what this works out to towards the end. And let's see what I did this weekend when prices were low. So during the night, you can see this prolonged 3.4 kilowatt. That is the car charging. No surprise here. So that's the most important energy draw that I can shift around in the week, because I don't have to charge the car every day. Depending on how much I drive, it's sufficient to only charge it on the weekend. And then you can see those little peaks here. That's the dishwasher heating up water and stuff and drying the dishes and things like that. Yeah, and the battery is not doing anything so far. Goodie. And then there was another low price point at noon, because there was quite a lot of sun that day and also quite a lot of wind. So electricity prices bottomed out again. You can take a look at this one here. I think it's this little down peak valley. This one here. Yeah, so we started charging the battery and cooking also. That was coincidental. We don't really cook by electricity prices. It just so happened to be. Yeah, so we charged the battery all the way full, and you can see afterwards we are not using the energy because prices are too low. And you have to calculate, say you charge the battery at 20 cents per kilowatt hour, then it doesn't make sense to discharge it at 22 cents because you've got the losses, say 25% losses. So the offset between the prices needs to be higher than those losses to make sense in order to use the energy. And then here you can see at 6 o'clock, suddenly we start firing up the inverter and offsetting our grid power draw. And apparently that's when market prices went high enough. Probably this peak right here from 6 to 8 o'clock. Right, and then yeah, prices dropped again. We stop the inverter and just use grid power till then. Now, let's take a look at to what electricity price this works out to. So in October we paid 34 euros for electricity, but easy, it's not the end price. And that works out to a base price of 18.1 cents per kilowatt hour. But that's not it. There's the fee that Tipper gets. There's the grid usage and the meter hiring, and then there's also the taxes. No, not tax, VAT. Well, it is a tax, value-added tax. So in total, we paid 54 euros in November for 190 kilowatt hours. But the effective price would be 18.1 plus VAT, so it's like 21.5 cents per kilowatt hour. And that for Germany, that is pretty good. If you have a regular tariff right now, you will be paying like 30 cents, 35 cents, sometimes 28 cents or something. So the only way to get lower than that is, I think, by using spot market prices. If you have an EV or a heat pump or some other bulk energy user that you can shift around with some flexibility. Right, so I hope this little insight into my energy management was somehow interesting to you. I will put links into the description to GitHub, to all the various scripts that are controlling this. It's written in Python. Maybe it can be useful for you as well. Yeah, anyway, thanks very much for watching and see you next time. Bye bye.